Faculty Development Program organized by SRM Madurai College for Engineering and Technology. It gives me a pleasure to welcome you all to Day 4, Session 7 of this FDP. Today's session is centered on the topic, a framework for developing IoT-based EV solutions, Ideation to Productization. Dr. Ramya S. Murthy is the founder director of Nimaya Innovations Private Limited from Chennai, and he has spent the last 10 years of her life working towards a singular goal to help children with special needs. Nimaya Innovations is one of its kind pioneering company that employs use robotics in the training of psychomotor and cognitive skills for autism spectrum disorder and other multiple disabilities. Dr. Ramya developed Suprayoga and IoT-based cloud monitors devices and training methodology designed to augment existing occupational therapy programs that helps accelerate the rate of learning by more than 60% children with ASD. Dr. Ramya S. Murthy is a recipient of the Devi Awards 2023 by Indian Express, Women Transferring Indian Award 2021 by NITI Ayog. Nimaya Innovations has also been awarded Innovation of the Year Award by the Association of Lady Entrepreneurs Telangana. Dr. Ramya is an Inspire Fellow, IAS Fellow 2018, University Gold Medalist MTech Robotics. She has Bachelor's in Electrical and Electronics Engineering. Her work has also been published in several international scientific journals on robotics. Participants can clarify your doubts at the end of the session. Post your queries in chat box. The session handed over by our resource person, Dr. Ramya S. Murthy. Thank you, and wishing everyone for an engaging and enriching session. Please, ma'am.
Thank you so much, sir. Thank you so much. Yes, I will do that. I will share my screen now. Please let me know if you're able to see the screen so that we can continue working.
Visible, ma'am. Yes,
yes,
visible. Yeah,
yes,
visible.
okay. All right. Good evening, everyone. Thank you so much for your time. I know how everybody is super busy, and having to sit through FDPs in the evening is not an easy job. I also teach in MIT, so I do understand the difficulty of that. But I'm very happy all of you here, and thank you for giving me this time. Okay, to start with, I am going to give a very brief introduction about what I do as part of my startup and what my research area is, and we will be going straight into what kind of EV challenges that we have in today's world. When we are going through this, I would request this to be a very interactive session. I just have a very few questions, and you can type it down in the chat box, or you can choose to unmute yourself and then talk to me. Either is fine. I'm very happy if somebody is going to unmute and talk, because I love doing sessions in person. So having a session online is always challenging. So I would love to have any kind of interaction with the audience today. So hi, I'm Dr. Ramya Murthy. I think we've said that enough number of times. So what happened was, as part of Nimaya Innovations, which is our startup, we develop robotic devices to train children with autism, cerebral palsy, mental retardation, and all of that to help them in their daily life skills. So the interesting thing is that I ended up in a very difficult time of my life where I had a serious fire accident, and I ended up losing all of my work in the fire. But as part of my PhD, what I did was I was working with a set of students across the country to work with. I was developing robots to train the children in disability sector across the country. And one day when I was in the ventilator, I was pronounced dead, and all of that happened. When I came back home, and I had lost my voice for about a year or so. So when I came back home, I received a call from one of the staff members who was training a child as well. And the important thing that happened to me was that phone call changed everything for me, because they told me, because I used robots to train the children, the child who was diagnosed with zero psychomotor skills still remembered what I had taught a year ago using the robotic systems, and he was able to do everything even right now. So that changed everything, and that is when I decided that we need to start a startup based on the work that I have done, and that's how Nimaya Innovations came about. So I think that is for a completely different talk altogether. But I just wanted to give you that a background of what I work in. So I am predominantly into robotic devices, mechatronic devices, and all of my systems are IoT based devices. So right now my systems are running in Chennai, Jamshedpur, Bangalore, and I get data where I am sitting, wherever I'm sitting. I'm right now in Manipur, and I'm getting every single data from all of the devices that's running around the country right now. So that is just to give you a basic idea about why IoT is so important in a real life scenario, right? So of course, I'm sure there have been several FDPs which has already kind of given you an update about EV vehicles and what is an IoT and all that. But just to give a very, very quick introduction, IoT is nothing but Internet of Things. So most of the companies hire IoT for three major reasons, right? So one is, of course, they want to reduce the cost. Either it could be the capital or the running cost, because every single time for somebody to go and figure out what is happening is going to take a lot of time. The major importance of IoT is the collection of data that you get, right? So it can be as simple as a smart home, or it can be as complex as a airplane engine that you are tracking. But all of this leads to every single particle of data that is going to eventually somehow help the actual problem that we are facing. I know it's a little vague at the start, but we will get into it deeper. So, and most importantly, they would like to increase the efficiency of it. So how do we do this? IoT is basically three main divisions, right? So one is the things, the second is the gateway, and the third is the cloud. That's how simple it is. So Internet of Things, that things is the first part. The second part is the gateway, and the third is the cloud. So what are things? Things are nothing but sensors or any kind of device that is going to give you any kind of data that you can track. It could be analog, it could be digital, it could be any form of data that it is going to give. But of course, for us to get this data, there has to be some kind of a sensor that is being integrated, right? For example, we go switch on the fan. With the wind that we are getting, we know the fan is on and off. But the same thing you need to know when you are far away, like 800 miles away. How are you going to do that? If somebody is going to walk into your house without knowing what is happening, how are you going to do that? I don't know how many of you have come across this movie, but there is a movie called Minority Report. It actually came in 2002, interestingly. It was such a far ahead of thinking movie. What they didn't name at that point of time was Internet of Things is what is being used. If anybody gets time, please go online. It is a movie by Tom Cruise. And the Minority Report is nothing but they somehow predict the future accidents that's going to happen. And there is an entire tag team, like Black Cat or whatever you want to call them, who will go, who are deployed to avoid that accident, right? So it could be a death of somebody, it could be some kind of a rampage, it could be a stampede that is happening in Kumbh Mela right now, it could be any kind of an accident that is happening. What happens is these people are able to predict it beforehand, and they are deployed to that particular site in so perfect in time that they are able to avoid the whole accident. In hindsight, or in the foreseeable future, that is exactly what Internet of Things is going to do. You are going to be able to predict every single data that is going to happen. You're going to understand every single incident that is going to happen and make sure that we are able to deflect it or stop it even before it is happening. So that is where your Internet of Things comes. And how will you get to know all of these data? Through sensors, right? And then what is your gateway, right? So your gateway is nothing but, say you have different sensors, you have different devices that is all being connected and interfaced. Now, how are you going to read each and every single one of them, especially when they work on different protocols? And I'm sure all of the professors here are aware of all the protocols and the networking and everything. So I'm going to keep it very, very high level. So it all works on different protocols, and you might end up getting analog data. So for example, in temperature, you will end up getting what the temperature is, right, from a temperature sensor. But if you're going to use an IR, you're just going to get a 0 or a 1. And then if you're going to use an ultrasonic, you get a distance. So each of the output or each of the data that you receive are in different formats. Now, all of these have to be processed, put together, and we should make sense of that data. So there is going to be a microcontroller or a microprocessor handling all of this as the mother brain, to figure out how to read each and every sensor, put everything together. And of course, next comes the place where you need to store all of them, which is your cloud, right? So you have your sensors, then you have this whole microprocessor and everything. I will explain a little more about the gateway. When we say the gateway, it just does not mean the microprocessor and the microcontroller. It also means that it has to have some kind of a form of an application where you can read or you can give some kind of an input or you can understand of what is happening. So all of that put together would be your gateway. And then comes your cloud in which you store. So there are two types of, two different ways in which your data is being stored. So there are two ways in which the analytical part can also be done. One, in the gateway itself, you can provide extra memory, or you can provide some kind of a accommodation where the analysis can be done right on the system, right? If that is not something that you would be okay with, then what happens is you can always store the data in the cloud and the analysis can be done later on in the cloud rather than being done on the entire system. So these are two different things in which IoT can be worked. So of course, just like every single system that we have, IoT comes with its own set of advantages and disadvantages. So just a little bit more about what a thing is, because once we go into EV, we should be able to relate this to the EV sector as well. So now what happens here is things are basically that is confined in clients' locations, right? In our case, it will probably be in any EV vehicle. We will go into that. Let's take a smart home for that reason, right? In this case, just to give you an example. So this could be sensors like, if there are plants, you're going to water the plants. If your gas is on, we need to check that. If your front door is closed, if your fans and lights are switched on, every single, if the main switch is on, all of this comes as part of your things, right? All of those are locations in the client's place. Then comes your gateway, which has to work with the IP protocols and the non-IP protocols and everything that is required, right? The gateway is nothing but something that connects the things to the cloud, right? So that is what your gateway is done for. This gateway can either be your phone or some kind of a system that is already put up in your house, or it could be a combination of both. And this, of course, will also either be in the client place or it can also be in the service person's place, where they are the ones who are providing the service. So they will keep track of what is happening in your house as well. Then comes your cloud, where you end up storing all the data and you can always view the data from wherever you are. So coming to the challenges in IoT, the biggest challenges that you could find is that what if you don't have internet? There is literally nothing you can do. Right? For example, I was telling you, right, I ended up in a fire accident. Now imagine that entire house was automated. Perfect. I mean, that would have been great. Somebody outside would have somehow figured out we were in trouble. But the fire, the moment it was caused, it kind of cut every single wire circuitry. So did the Wi-Fi and every single module along with it. Now, can the data be transmitted? No, right? But the moment there is an anonymous way of this working, your cell phone will immediately get an alert telling there is something wrong because the entire connection is cut off. So that itself should give you an idea. That is also a way of Internet of Things. So one of the biggest dependency of Internet of Things is that the Wi-Fi connection or your internet has to be, available. The second one is depending on the amount of sensors that you are using, depending on the amount of parameters that you are going to read, the gateway complexity constantly keeps increasing, right? You may not require just like a regular Arduino or a ESP32 or any other microcontroller. You might require a master slave mechanism that has to work, or you might require a much bigger array of microcontrollers and processors that needs to work together to give you that kind of a very complex three-tiered level gateways. So that is another problem that we have. Another important thing is, what if the data gets breached? This is something that is happening quite often right now, right? Be it your WhatsApp data, be it your bank account, be it any kind of account that has been there online, it is easily getting breached. So authentication and data security is very, very important when it comes to IoT. And of course, low power circuitry has to be taken into consideration. High voltage circuitry has to be taken into consideration. But that all comes under the hardware software part of it, and we can go into that later. So these are a few of the challenges that comes as part of IoT. I think that's clearly given here on the slide for you right now. So it is IoT is ultimately best for data collection. We're just going to summarize what we've seen for a bit right now. And sometimes what happens on top of the complex gateways, your response time also becomes a problem. Say you have a network connectivity issue or some kind of a sensor malfunction, then the response time that you get the alert may not be completely dependable, right? So this can lead to failure. And of course, if it's going to be a public network, then of course there's going to be a problem. And of course, we already spoke about security that is being compromised. Okay. Coming to what makes up an IoT solution. So as far as technology is concerned, we have already listed it right on the screen. Very simple. You have a set of sensors. Then you have a set of electronics that has to host the set of sensors. There has to be a communication medium, a cloud infrastructure, and an application that is running in the gateway and in the cloud. Right. So why do we require an application that has to run in a cloud and the gateway? In the gateway, it is for you to understand what kind of data is coming in, how we are going to process, and how we are going to look at it, and how it can be analytically changed. Now, in the cloud is where you actually get your data, right? For example, say the same home automation situation, say there is going to be a severe increase in temperature. So you're reading the temperature, there is an application running in your microcontroller microprocessor that is going to give you an alert. But there has to be some kind of an algorithmic pattern that is running to figure out how often this happens, right? Also, why it is happening. All of that is going to happen in your cloud, where you're going to run your AI, ML, whatever software that you want to run with a proper GUI application. So if this is the technologies that you require, what are the devices and applications that you would require in your IoT solution? Of course, I think we've gone over this over and over again already. Things, gateway. Of course, we need a service provider. It could be any of the third parties that you want to work with, or there are several other applications that you can use. You can even use any other different wireless protocols, let alone Wi-Fi. And then, of course, you need a large amount of cloud storage, depending on the applications that you need. All right. Now, before we start with the next section of the EV part of it, can anybody in this audience tell me, are anybody already driving an EV vehicle? I would love for them to unmute themselves and tell me if you're already running an EV vehicle, or if you're already driving an EV vehicle. Any messages in the chat box? Okay. All right. So I'm going to assume that all of us are still in the fossil fuel situation and petroleum and stuff. Okay. Because there are a lot of people here in Manipal have surprisingly taken to EV vehicles, be it bike, be it scooters, be it any kind of cars. And I can every day see a lot of challenges that they run into. However, it is very silent. I mean, there's huge number of advantages for an EV vehicle, right? It's extremely silent. It is, environmentally very friendly. I think the sharing of the screen is gone. Just give me a second. I'm going to share it again. Sorry for the inconvenience. I hope you can see it.
Yes, yes.
Thank you so much. So, coming to the EV sector of the vehicles, there are both pros and cons of an EV sector, right? Let's take the EV vehicles that is coming up right now. What are the pros? Most importantly, it cuts down air pollution big time, right? Because it is running on battery. It does not use petrol anymore. Of course, there are hybrid vehicles which use both run on battery and petrol right now. But of course, pure EV vehicles really helps the environment. Complete decrease in carbon emission. Knowing the situation of how Delhi turns out to be in certain part of time, and how Bangalore's pollution level has been increasing in a very alarmingly large rate, and looking into how it has been affecting our environment around, I think it is high time that EV sector picks up quite a bit, and all of us start shifting into EV sector as well. Most importantly, low operating cost, because we all know how much we end up spending for a liter of petrol. And that is the commendable fuel economy situation. Of course, low maintenance as well. But the same set of pros do come with a set of cons. EV vehicles are very expensive to start with. Operating costs are low, but the capital that you actually have to pay upfront is quite a bit, right? And most of the car, I think so far, if you take Tesla is giving you the maximum miles per charge. But right now, I think the maximum is about 370 kilometers. And people have not been able to achieve more than that right now on testing, real life testing conditions, be it Mahindra, be it any of the vehicles, Tata, Nexon and everything. So of course, they're getting better and better every day. Dependency on an electricity grid. How many of you there in cities right now are able to find charging stations everywhere? Here I stay in Manipal, and I can tell you hands down, this entire stretch, there is not one electrical charging station except for one petrol bunk somewhere there where they have a couple of charging stations, right? Right now, everybody in Manipal are using their plugs and everything at home, and they charge their vehicles. But this is one of the biggest dependency, right? We don't have a lot of charging vehicles. A very interesting story that you want to check out on how our EV sector is running. When Tata actually sponsored a couple, rather the couple started their journey, but then Tata got onto it later. The couple decided to drive from Kanyakumari to Kashmir, this end to that end, in an EV vehicle, right? They set on foot and all of that. I mean, they started and they went wrong, and they realized this was easily 2-3 years before when the EV sector started picking up. They found out that they could not charge their car in so many different places. So what happened was Tata was so unbelievably supportive, and also they understood what kind of situation they would run into. They ended up supporting them in various garages and warehouses. They had a portable charging station that was brought to them so that they're not stuck on the road. It is a very interesting YouTube video that all of you can check and see how it is, like how the entire journey went by and why EV sector has to be concentrated upon. All right. And coming to the next one, of course, a longer recharging time that has gotten a lot better. I mean, I still remember the time where we used to recharge that 1100 phone, which was technically what was allowed in SVC at that point of time. I'm sure Venkateshan sir can recollect this. Will take all night to charge. Right? Yes. Now I'm able to charge my phone in like 2 hours or so. So I think all of us have gone through that phase. So that gets better, but the dependency is still high. And the most important part that I am going to talk about today is the limited after-sales service options that is available. How many of you can relate to that? Even with a well-established petrol vehicles or a diesel vehicles, only certain brands give you extremely good support. And the rest of them are still, trying to support the best way they can. But in case of EV, the limitations of after-sales support is very, very hard, because at least in our case, say, for example, all of us buy a car 2-3 years later, once the warranty is done, we'll end up taking to a local mechanical who will basically handle all of our needs, right? But that cannot be the case with EV. The problem is the local mechanic does not have a lot of idea about how the whole EV battery works, or they are not given enough information, and there's not a lot of diagnostic tools to handle either. So that is what we are going to talk about later. Now, coming to the why, the whole topic is about why IoT is required in EV vehicles, right? So, so sorry. Post the accident, this cough has been going on for years, so you'll have to forgive me if I keep coughing in between. So, top IoT applications in EV vehicles is what we are going to see now as to why this is required. Vehicle connectivity. Vehicle connectivity is nothing but it could be a communication of your vehicle to a GPS system, or it could be communication of your vehicle to another vehicle. Kia right now, all of their cars comes with proper GPS connectivity, right? So the owner can put it on their phone and figure out where the car is going, right? So most of the cars have come in with inbuilt GPS systems, and that also comes as part of the connectivity. So it can be a vehicle-to-vehicle connectivity or vehicle-to-a-device connectivity. It can be any connectivity, and that's what we are talking about, the vehicle connectivity here. Then comes the predictive maintenance. What does predictive maintenance mean? Predictive maintenance, in short, can be said that whatever may go wrong has to be predicted beforehand, right? So that's what we are looking for. Why do we need to know what is going to go wrong beforehand? So that we will stop from any major disaster happening. So say you're driving down from Chennai to Bangalore. It's a well-connected route, no issues at all. You're taking your EV vehicle and going down. And without you realizing, your battery has been constantly draining. Now what happens? The problem that happens is you will run into trouble, but you will not know how to fix the whole situation either. So imagine the same thing. You are going to know it beforehand. How easy would it be for you to figure out that, oh, my battery pack is showing some kind of an issue. So maybe I should fix it before I take the travel, right? That's the simplest way to do it. Now we have three different things: energy management, EV charging management, and battery management. All of this sounds very similar, but let me tell you the difference between the three. Energy management is nothing but how your battery pack is connected to the rest of your parts in a car or a vehicle, any vehicle, right? So just like how our body is connected in different parts, of course, your battery is going to be connected to different parts of your car or your bike or whichever vehicle that you say. Now how they are connected, how are they operating, how each and every amount, how much volt is being sent to each of them, that is your energy management. Then what is your EV charging management and what is your battery management? Battery management basically makes you understand the life cycle of the battery itself. For example, I told you, if your battery is draining prematurely, then we'll have to know it beforehand. So your life cycle of the battery, the temperature of the battery, the battery's capacity to charge every single time, all of this comes under battery management. EV charging management is a very interesting concept that has gotten into EV because in regular cars, we don't really try to put petrol in the house. You only go to a petrol bunk. That was one given place where you go, you pay, you get the petrol and you're moving on. But in case of EV charging management, what happens is different charge points work differently, right? There is a heavy possibility that there might be some kind of a circuitry issue, or there could be some kind of an over voltage that has been sent in. I mean, I don't know how many of my electrical professors are saying, but yeah, I've moved a little away from electrical through my life, but I hope they are going to be very happy with the amount of work I've done. So EV charging management is where you're going to charge in your house. Then there is going to be an AC-DC supply change. So now how does your system work based on your DC supply that you're getting, DC charging point or your AC charging point? All of this is where your EV charging management is taken into account. Fleet management. Fleet management is nothing but, I'm sure now in every city that you are, you will be able to see a lot of EV vehicles that is being left, right? Like 5 or 6 vehicles will be left at a point. You can scan the QR code and you can start using it and driving it from one point to another. Now, this is where the fleet management comes in. How many, using the GPS positioning and in other sensors that they have inbuilt in those bikes or cycles, they will figure out how many are parked at the same place, from which place to which place did it move, how many of those bikes are close to each other, do they require any help? All of this can be tracked. That's your fleet management. Personalized user experience. With the upcoming cars, you already know, like we of course connect to Bluetooth onto our, our audio system, and we like to listen to music in the car, but sometimes we want to take a call. So now imagine our car basically understands our behavior completely, right? So what it does is basically it understands the moment you get into the car, you like to listen to the music from the car radio system, but when the calls are on, you want to take it in your Bluetooth. This is something the device will understand, learn, and keep it with itself, or you will have to teach it. Is there a question? Should I pause? Okay. I guess I can continue. Please let me know, because I don't have access to your chat right now. So if you want me to pause or anything, please, sir, let me know. So now what happens is that is what your personalized experience means. So this is where all of your IoT-based devices and IoT-based connectivity is required in EV vehicles. I'm going to take like a second to sip on some water. Just give me a second. Okay. So taking all of this into account, one of the things that I wanted to address here is that the post service that we get for an EV vehicle is very, very difficult. Now, when sir approached me asking what I could talk in EV, I was sure that most of the people would have covered how to design them, how to develop them, fuel, energy, and all of that. The one thing that I really wanted to get across is if there is a problem in the EV sector, how is that problem becomes an idea, how that idea is going to become a product, and how that product is going to be implemented. So this framework that you are seeing online is copyrighted by me, and it was a framework that was developed by me for my own systems. So I'm implementing that framework here to help you understand how an idea can be made into a product in the EV sector, in IoT being in consideration. So here city means study, identify, engineer, test, and implement. So we'll be going one by one, and you can pause me at any time if you have any doubts. Is there any doubt so far? I'm hoping to take another half an hour or a 40-minute stretch, and then we can open for questions. Is that okay? All right. So the first issues that we find in IoT-enabled battery management system for two-wheelers or EV is what we are considering here. So first thing is that the lack of accessibility to service. So we are not able to have any random person touch the bike and say, you know what, it's just a wiring problem, let me fix it. But that was much easier in the well-established, already existing vehicle system. But that is not the case in EV vehicles at all, because there's a lot of knowledge gap that has happened, because most of the mechanics who are locally working do not have any idea what kind of battery pack is being used, how they are supposed to be used, how they are supposed to be handled, what temperature it should go to. None of it has been understood in total. Can somebody tell me if all of you have come across this Ola electric bike automatically combusting? I'm sure all of you come across in the news. Like, one of the reasons why they found out
Rania ma'am, audio is not coming.
So can you hear me now?
Yeah, it's clear, ma'am. Clear. Yes, thank you.
Are you able? I mean, my screen is not. I mean, it's not shared, right?
Yes, ma'am. Yes, ma'am. Not sure.
Is there any doubts, or should I pause for anything right now?
You can, Rania. End of the session, we'll ask.
Okay, sir.
Thank you.
Perfect. Perfect. Okay, so let's move on to see how an idea. I'm getting a feed from somewhere. Are all the mics on mute? Yeah, it's better now. Thank you. So let's let's figure out how each of the steps are going to be followed. Right? So the first part of the city is study. What does study mean? Initially, we need to figure out, all of us are researchers here, so you obviously understand what study is. Not trying to be patronizing here. But we initially, when it comes to an EV sector, why the study is so important is what I want to implement here. The reason is all of us are not used to the EV sector as established as the other cars are, right? So now what happens is, the first part of the study has to be what are the different components that the entire EV vehicle has. What kind of management system would each of the components require, right? And of course, later on comes the fact that the mechanics have very limited knowledge about the EV, and most importantly, they don't have a diagnostic tool that they can work with. They don't have an app, or they don't have a manual that's going to give them an idea saying what these are the few sectors that you need to check. This is how you need to check for the brake. This is how you need to check for the braking, the heating of the pad. None of it has been taught to a regular mechanic. Of course, you take it to Ola service center. They have a trained set of people who will handle it. But say you are stuck in some godforsaken place where you don't have access to Ola, right? Like we get a tire punctured, we can go to any puncture shop, get it done. Say we are on a highway to, some very rural village. Any mechanic there would still be able to handle your car until you're able to get back to your station. But right now, with the EV, that is not the case. It is a bit of a risk to even take it out of your own city because you don't have access to the correct amount of help that you require. So the next part is we have to do a bit of a market research to figure out what are the existing EV battery management solutions that's already available, which are the ones that is easily available for the local vendors and their repair works, and how they are going to repair it, and how the networking works, and all of that. Then, of course, comes the technology exploration. So what are the different type of sensors that might be required, or what are the sensors that is being used right now to sense? All of this has to be taken into account as well. Most importantly, the one part that we usually miss out on is that, just a second. Yeah. Most importantly, what we miss out on is that we forget to get the feedback of the user, right? In this case, all the stakeholders involved are very different. So one is the person who bought the vehicle. It could be the same person who is using it or somebody else is using it. So the user feedback is very, very important. Another thing, the mechanics who are going to work on it, their feedback is also very important to see where are they facing the difficulties or challenges to handle this scenario. So the whole outcome of this study part is to have a deep understanding of challenges with EV battery servicing, what information is needed by the local mechanics, and the types of technologies that could address this problem. That's it. That's where your study network stops. So you can see just with this picture that is being viewed, in one regular EV cycle, there are so many different parts that needs to be taken into account, right? You need to understand how each of the parts are going to work, what kind of sensors are being used in each of the parts, and how are you going to read each of the sensors. Now that the study is done, next is the important part of identification. Okay, we sat and figured out all of these were the issues, but what exactly are we going to address is what is important. For example, in this case, what I have taken is I have simply identified our biggest problem as battery health monitoring, right? Because I didn't want to keep a very broad area. I didn't want to give way too much information overwhelmingly. So I just wanted to keep, let's take battery health monitoring. What are the battery health monitoring situations that we have? What are the parameters that we are going to? We'll have to check for voltage, temperature, charge cycles, current flow in real time as to when the system is running, what is the current flow, when it is at off, what is the situation, and all of that. These are few key parameters that we need to find. And we need to find a diagnostic tool for mechanics to handle all of these parameters. Most importantly, okay, fine. Right now we figured out what are the parameters that we are going to see. But how are the user going to understand this is the issue that is happening? So you will need alerts and notifications that is going to come either to your phone or to a tablet or whichever monitoring system in one form or the other, right? And most importantly, along with the alerts and the notification, the owners have the right to understand how the battery insights are going to work, right? We have to provide the usage of battery patterns. We'll have to read how the user is actually using the bike. For example, let me give another real-time story because it will be a lot easier to relate to. Now, insurance companies, I don't know how many of you are aware, but this is a lovely thing that I came across yesterday, very recently. So insurance companies are talking to the car manufacturers and they are having extra parameters and sensors built into the car in such a way they figure out your braking patterns, how much of you are speeding, overspeeding at what point of time, and at what level are you switching onto the clutch, how are you braking, how are you turning. Every single pattern is being formed, and there is an AI ML algorithm that runs, figures out if there is an accident at that point where you on super high speed out of, where you're running on a high speed that was not supposed to, that was illegally high, or did you brake in a wrong manner. And if they find out that it is any time between the threshold, your insurance is null and void. You do not get the insurance because you cannot claim it anymore because this was your mistake and that is something that you cannot claim. So insurance companies are working on that, and that is completely purely IoT based devices. So this is where the predictive maintenance as well comes in, right? So this helps you in all the predictive maintenance. Now we have studied what the issues are. We have identified what are the parameters that we are going to study. Next comes the most important, and the part that I love is the engineering. For that, can anybody identify what you're able to see on the screen? Can anybody type it down the chat box or just switch on and let me know, like unmute and let me know what it is on the screen? Any guesses? Okay. All right. So what you're seeing on the screen is nothing but a Boeing engine of an air flight, right? Of a flight. Now, why I have put this image here is because can you see the complexity of the wiring that is there? So Boeing, Airbus are different companies that run, that basically manufactures flights. Now, what do these people do is that they do not all the time do they manufacture the whole flight. They mostly provide engines for a lot of other companies which manufactures flight as well. The important factor of it is each and every flight tracks at least 3 lakh parameters. I am not kidding. Every flight tracks 3 lakh parameters to make sure all of us are safe in the sky. Literally, because we are all flying in a metal tin and they want to keep us safe. So 3 lakh parameters has been tracked every single flight. And this one engine alone, they track from 2000 to 6000 parameters, right? From the vibration, right from, the temperature, how much the engine has been used, at what point the engine was, hit the brakes and when it stopped, how much the turbine spins for it to stop. All of this has been tracked just so to see the health of the engine over a period of time, to make sure that it is not, to make sure that it is not been degenerating, and to make sure that the health of the engine is fine, and to make sure they will predict it beforehand, even before it gets off from the runway. All right. Coming to the engineering part, right? So, hello. Okay. Coming to the engineering part. So now we figured out battery health monitoring system is the one that we are going to figure out, right? So now how are we going to do this battery health monitoring system? We of course know it is going to have a hardware, it is going to have software, it is going to have security, 3 parts. So one is your hardware, one is your software, that the other one is your data security. In your hardware, you will have sensors, IoT sensors. connectivity, making it a diagnostic device. I'll tell you why and how we are going to test the diagnostic device in the next slide. So now imagine you end up putting a set of sensors to track the health of the battery pack, right? Following the life cycle of it, the temperature, voltage, current flow, everything is being tracked continuously in real time. Now we use a Wi-Fi protocol where it sends all of this data either to a gateway to figure whatever needs to be happening there, or to a cloud to store. So this will in entirety will be the diagnostic device, because this is the one that is going to track the system completely. In addition to that, we can develop any other management system that, for example, if you take a car to a service station, to Hyundai or Tata or whatever it is, they will immediately take one tablet with a plug it into your car system, and then they will click a couple of buttons to see how the entire health of the car was. Right? It is basically like how we end up doing like a sugar test or a health checkup once in a year or so, right? Immediately you get everything in one tab telling, your car is this, your system is working at this level, this is how it is, your engine is aged so much, everything lists down. And this helps them clearly identify which are the problem areas, which are not the problem areas, and where they need to focus on. So this is the hardware part of it. The software part of it is like we are viewing on a tablet, right? So that application has to be developed for it. A mobile app has to be developed, a web app has to be developed, or whichever that is required in whatever form you need it has to be developed. And this should be able to read every single parameter. And of course, in the cloud, you will have its own set of platform that will run your different algorithm, give you graphs, give you diagnostics, give you any kind of alerts that is required. And of course, I don't have to talk a lot about security. The security part has to be very, very foolproof, right? Where not a single data of anything should get out, because if there is a breach, then everybody in that entire string is going to be penalized. Now, this, as you can see, these are two different battery packs that is being used for two different EV vehicles. So when it comes to EV bikes, I think few of the very familiar companies are Ather. Ather has been doing very well. Ampere, Ola. So these are few of the EV vehicles that is being used. And the reason I was showing you this is every battery pack, of course, comes with the casing, correct? Now, as part of engineering, there is something that we'll have to foresee, is that the entire designing of the casing and the wire circuitry and everything has to be changed based on what kind of sensor you're fitting in, how you are going to route it, where it is going to be routed, what kind of microcontroller is being fit there. And every single thing has to be taken into consideration and redesigned based on that. A new casing and a new engineering aspect has to be developed for your system to work really well. So this is your engineering part of it. Sorry. Okay. So next comes the testing part. Okay. So when it comes to the testing part, I think as far as all of us develop a prototype, the thing that we know is we test it, we figure out there are issues, we debug it. Software developers completely sit alone and figure out what are the different issues that is happening, and then hardware people figure out where are the things that we have a block. We figure out if there is no flow somewhere, and then we fix it. But when it comes to an EV vehicle, what can I say? Sorry. The challenging part of it is that, say, for example, in the previous one, you can see the battery pack, right? In this battery pack, you have fit in the sensors. And before you're fitting in the sensors, the setup alone has to be tested separately. That's testing number one, right? The setup alone has to be tested separately. And then you're going to fit it into this battery pack to see if it is perfect and check if it is all right. And the testing inside the battery pack has to be done to make sure they're placed correctly, they're connected correctly, and they're working correctly. Now, this battery pack has to be put onto the system in an idle mode, test if all the fittings and everything is okay, and the power circuitry is connected fine and all of it before even moving it. Then comes your testing, where you run the device for several hours and several minutes and whatever area that you want to run it in, to make sure that in the running module, whatever changes that needs to happen, that needs to be done as well. Once again, you have to remove the entire setup and do all of these reverse testing again to figure out if both the results from both the testing match the same, showing you that the life cycle of that battery works fine, right? So just for a battery health management system, so much of work is being done. Okay. On top of that, other than these level of testing, this will come under the prototype testing, and the one that I was telling you about, where you put it in a vehicle and then you run it along, will be your performance testing. Other than this, your separate battery has to be tested. Security testing also needs to be done, and user testing. So far we were talking about how this system that we developed fit into this battery management pack and how they are going to work. On top of it, you do realize that we have developed several applications and a diagnostic tool for the mechanics to use, correct? So shouldn't we have a separate set of testing for the softwares, right? So now what happens? We run alpha testing, beta testing, and more on. So what is an alpha testing? Alpha testing is nothing but we end up testing our device in our place as and when we develop it, right? And then once going on to the beta testing, you will end up deploying it in specific targeted areas. Say first you contact a local mechanic and tell them, you know what, I have so and so, would you like to try it, right? This would help you in so and so and so. You give him a list of advantages that he would have. You, most importantly, comes the next part, where you need to train him to use the same device. So meaning you have to be very particular when we are designing the application, that it has to be so user friendly that it should be able to reach the target users very easily. So if it's going to be the mechanics who's going to use the diagnostic tool, he should not be given a very multi-layered complex scenarios where he has to click several buttons, fit so many things. No, it should be as simple as clicking one single button, plugging in, and the moment he will look at it, he has to know how everything needs to happen. He may not understand the nitty-gritties of how the device was developed, neither should he, but he should always understand how the system should be diagnosed at the fraction of a second, making it easy for the user who has come over and also for him to learn how to get along with this EV sector, right? So this is what happens when we have to take a targeted set of people, try these applications in a few cities, then expand it, then you can use the scalability and then keep going on. And that is where your implementation parts come in, right? So your system is tested, you've done your alpha testing and all of it. Now comes your implementation part. I would rather call it as a pilot deployment, because we are still not gone as a product, right? Because our entire talk today was about how to make an idea, how to take from an idea, from a problem to a solution to a product. So first we end up deploying it in the pilot testing mode, where we end up taking a set of people who are going to work on these or use these diagnostic tools to diagnose any single EV vehicle that comes across. But the important part is you should closely watch and maintain all of these data and document them to see where they are finding it too hard to work with, where the changes are required. So that would be your feedback loop, right? The moment they start using, they would come back to you and tell you, no, this is not okay. This I'm finding very difficult. This I am not able to understand. Once you start collecting the data across several set of people, you will kind of form a pattern to see which kind of user interface needs to be changed, which aspect needs to be transformed, which features needs to be added or removed. All of that will become very, very apparent. The important part is the user support of it should be given very well. So you are the one who's providing the product. So you need to be very clear to make sure that you have a person to support that product, to make sure that you handle it from the start until the end, until the user is completely acclimatized to using it, right? And the important part is this is something that is coming from a personal point of view, personal experience. So when we designed all of our robots, I had to train a lot of children with autism. And so I usually work with special schools and special educators. So I will give them the robot and they have to use that bot to train the child, right? Now, the biggest thing that I found at the start was that I developed a Suprayoga methodology that will work for this device. But now I have to standardize my training across all of the therapists so that everybody will get the same output, right? So just like how everybody has a very standardized set for developing an EV, the same set has to be given in the training as well. So you need to have a set of standards that you need to follow. You need to understand what kind of implication factors that needs to be taken in. And you need to understand how to train each and every mechanics across different languages, different demographies. All of that has to be taken into consideration. So yeah, so that comes us to the implementation part. And of course, once you are very confident about what you've done in a certain sector, you can always scale it to a much bigger environment. And so the most important part is the outcome of this is a fully implemented solution that improves battery maintenance for both EV owners and local mechanics with the potential for nationwide adoption. So meaning EV is going to be inevitable, right? Tesla is doing so well in the Western countries, and here it is picking up as well. And we all know it is great for the environment and it is going to be there. But how are we going to make this adoption very, very easy is what we're going to look into. And this was just one of the many frameworks that can be developed, used to devise a concept from the concept to a product. Once all of this implementation is done, take the feedback, please go back to it, make sure that every single feature change and everything has been redesigned, and make sure that a much optimized device is being developed. Right. So, yes. So the whole point of this framework is study, identify, engineer, test, and implement, which is what we went through one by one. This process from ideation to productization helps to ensure that the IoT solution is well engineered, thoroughly tested, and ready for successful implementation in the real world. And that was the whole point of this entire PPT presentation. Yeah, I think that would be end of my session. We can open it to questions, or if there's anything else you want me to go back on my slides, or if you want to have an open discussion about the EV sector right now, we can definitely have a talk, and definitely more about IoT. I would be open to.
Thank you, ma'am.
Thank you.
Participants are requested to raise your questions, please.
Participants, kindly unmute your mic and ask your queries. I think it's very clearly, ma'am. So,
thank you. I hope so.
Okay, thank you, ma'am. Thank you, ma'am.
Thank you.
Yes, ma'am. We express our sincere gratitude to Dr. Ramya S. Murthy for delivering such an informative and more example to engaging session is very effectively, ma'am. Ma'am, your presentation not only for covered theoretical views aspects, but also provided a practical perspective and applicable, ma'am. As a woman, always inspiring in the world, but as a woman, you contribute to inspire many in the world of technology and innovation, ma'am. Your knowledge and dedication and contributions for aspiring professions, ma'am. Thank you, ma'am, sharing your knowledge. It's very good day. Thank you, ma'am. Thank you so much, ma'am.
Yes. On behalf of SRM Madurai College of Engineering, I congratulate Ramya ma'am. Your presentation on IoT are excellent and informative and highly valuable. Your dedication to supporting of implementing these special devices for special children is really inspiring. And I wish you get more awards in future and
Thanks.
praise for your good work and keep signing.
Thank you.
Congratulations and good.
Thank you.
Thank you.
Thank you so much.
Thank you, miss. All the best. Thank you.
Thank you. Thank you so much. Thank you, everyone.